Hi all, Dmitry is here, welcome to my next video about the battery testing. And today we will test GP batteries. As you can see, we have lots of them today. We have rechargeables, and we will test rechargeables at the very end of this video. We have two sorts of zinc-carbon. We have GP power cell and green cell. We have different sorts of alkalines. We have GP Ultra, Extra, and we have Super and Ultra Plus. I don't know what is the difference, but we have three sorts of Ultras and one sort of Extras. Let's test them. Also we have this peak power alkalines. It's not GP, it's peak power, but if you will take a closer look, it's made by GP Batteries Europe, so they made by GP, but they sold at a different brand. And problem is, I'm not able to find these ones in small package, only 40 pieces, so I have lots of them, but I need only a few. But okay, I bought this to be able to test them also, because they are also kind of GP. And also, of course, we have lithium batteries here. They are very light and they should be the best of all AA's in this set, let's say. Okay, so let's test them. I guess let's start with the zinc-carbons. We have power cells and we have green cells. Let's start with the power cells. Okay, let's start our testing of GP. First one will be this GP power cell. They are zinc-carbon and they are really light. Let me open the package. Actually, it's quite unusual to see zinc-carbons today. New zinc-carbons, they have expiration date in February of 2025. Wow, they are quite fresh. They have a metal wrap here, it's not plastic, it's metal, and they have a model or rating R6S. I will talk about these ratings a bit later, but interesting point that these green cells have R6P, so they should be kinda different. Let's take a look what do we have here.
Just one moment for you and a long time for me, and finally we have the data. Here we have the raw data for GP power cell, and as you can see, the capacities are quite low, just about 400 milliamp hours for 0.1 amp, so it's ridiculously low. And actually I'm surprised that these batteries are all still produced. And here you can see that the internal resistance is going up to half of ohm. It's incredibly high values. And as you can see, for 0.1 amp we have just low capacity, but for 200 milliamps we have just 200 milliamp hours, so it died really quickly. And for 0.5 amp it's almost nothing to speak about. It's just not suitable for currents like that.
Okay, we finished with GP power cell. Let's test another zinc-carbon kinds of GP here. GP green cell R6P. They have more expensive packing, not just plastic wrap. Let's open it and take a look. What do we have there? It's also metal wrap, not a plastic one. Also really light, R6P, and the expiration date is, I'm not sure, 01/26 I believe. So yeah, it's really, they should be really fresh. It's kind of super surprising for me that zinc-carbons are still in production, but okay, let's test these ones.
Here we have raw data for GP green cell, and we see almost the same picture like for power cell, because both of them are zinc-carbons. But here we have a slightly bigger capacity, about 600 mAh. So they have a slightly bigger capacity and slightly bigger internal resistance. For power cell we had 0.5 ohm almost at the end, and here at the end we have 0.7 ohm almost. So it seems like green cell should be better at devices that require a bit more, that require lowest currents. For example, I don't know, basically mood controllers, infrared ones, and I don't know what else it can be, maybe calculators. And actually I'm surprised that these batteries are still produced, because the price difference between cheapest alkaline and this zinc-carbon is not so high today. Okay, let's go further.
Okay, now we finished with zinc-carbons, and let's switch to alkalines. Let's start with GP Super, just because they are not extra, ultra plus or something, they just super. We have just super value pack, so they should be simplest alkalines from GP, I guess. Let's check them.
Here we have the raw data for GP Super. It's, I believe it's the simplest alkaline from GP, but we'll see. We have here picture more or less normal for all alkalines, about 2 amp hours. So it's not just slightly bigger than 2 amp hours. It's not how to say it, not something super extra, but it's a decent alkaline.
Let's go to next GP alkaline. Next one will be this GP Ultra Plus, 10 years of storage warranty, high performance. So yeah, definitely not value pack. They not proposed us something cheap, they proposed us something high performance. Let's try them.
Here we have our raw data for GP Ultra, and here we can see a slightly bigger capacity than GP Super, but at the same time here we can see that the maybe 18% of capacity, maybe 75% of capacity, internal resistance starts to growing quickly. So probably this amount of capacity, this amount of power will be unuseful on powerful devices.
Okay, let's go to next alkaline, and this one will be GP Extra. This one is ready to ship. I'm not sure what it means, because this one also looks like ready to ship, and this one's also. So I don't know what this means. If you know, please write me in the comments. And these extras are coming in 20 pack. And problem is I'm not able to find them in 4 or maybe even 10 pack, only like that. I don't need so many for testing, but it was just only one option to get them. So because of that we have lots of them here. Let's test this extra. I believe they maybe will be a bit worse than Ultra because it's a super value, it's not super performance or like that, but I don't know, let's check them.
Here we have the raw data for GP Extra. It's about the same like for previous alkalines from GP, but here for some reason, we have slightly growing internal resistance at first, and then it slightly dropping and stable until the very end. So this is quite interesting. So probably we have different chemistry in GP Extra.
We finished with GP Extra, and we have one sort of GP alkalines remain. It's GP Ultra Plus. New formula. Number 1 alkaline battery. So it looks like GP want to say us that these ones will be best of GP alkalines. Let's check this. Long-lasting power for hydrogen devices. So they should perform better at the high currents. Let's check if this is true or not.
Here we have the raw data for GP Ultra Plus, and actually it's quite interesting. Capacity is quite bigger, and we have a power line slightly more far away from the capacity line. This means that overall voltage is slightly higher than with previous cells, and internal resistance are quite low until the remaining 25% of capacity. So it looks good as for me.
Okay, and we have last alkalines for today. It's this peak power alkaline high performance produced by GP group, but they obviously not GP branded. If you will take a look at the battery itself, it's just 100%, and it's not branded as for me. It's just something, just some battery. No, okay. We don't have any signs of high current applications here, like we don't have cameras drawn on the package, we don't have flashlights or any use cases, so I believe they will be just moderate, just normal alkalines with nothing special here, but let's check if this is true or not.
Here we have the raw data for peak power, and again we have interesting situation with internal resistance. Here it's slightly growing first, and it's growing relatively quickly, and then it kind of falling a bit. And from these graphs you can probably think that oh, internal resistance are quite high, it's much higher than on previous ones, but no, take a look on the values here. Internal resistance for peak power are quite low for all testing cycle. It's not growing at the very end, and this is quite interesting. So again, the peak power have different chemistry than alkalines branded as GP.
Finally, we finished with alkalines. Now let's try these ones. Lithium batteries from GP. Some vendors have lithium batteries in their line, like a Varta or Energizer or GP. Some brands don't have lithium batteries, I believe, because they are quite expensive, and at normal room temperatures they perform not how to say, not so good. So price value for normal room temperatures may be not so good like in alkalines, but this is just my opinion. Now let's check what we will have with these ones.
And here we have graphs, raw data for GP lithium. It's quite interesting typical for lithium batteries. As you can see, voltage is very stable, and because I had only two of them, I had only tested them for 0.2 and 0.5 amps. I think it's just no sense to test it to test them at 0.1 amp, because they holding the load without problem. Even half of ampere is not a problem for them. As you can see, it's quite interesting. They have almost 3000 milliamp hours capacity and almost 4 watt hours of energy per battery, so it's super results from 4GP batteries. I believe rechargeables will give less energy. And from internal resistance point of view, they also looks quite good. Internal resistance is on very low level until the very end. So from these perspectives, from these graphs, lithium batteries looks like perfect AA batteries, because they have really high power stored in them, they have really low internal resistance, they handling high loads very well because the low internal resistance. But there is a catch. Take a look at the voltage graph. It's almost the same until the very end. So most electronic devices will not able to tell if these batteries will die soon, until maybe this point. But at this point, battery is already dead, I think. So just one trick, one problem with these lithium batteries, you will probably not notice that it will be depleted soon, until it will just stop working. So if you have some device and you're using lithium batteries, it's a good idea to have a spare set of batteries with you, because when you will notice that your battery is about to die, it will be too late.
Finally, let's go to the rechargeables. We have 3 kinds of GP rechargeables here. It's just normal recycle, 200 and 2600 milliamp hours, at least should be. Just plastic wrap package. We have Recycle Pro. I'm not sure why they are Pro and why they are better than normals. They don't have a capacity. Oh no, they have with small numbers. You can see, probably you can see 2000 milliamp hours, only 2000, but they are professional. This one is not professional, but for some reason they have much bigger capacity. So probably these ones will have less internal resistance. Let's check. And we have special Recycle Pro photo flash rechargeable. They claims that these have fast recycle time, so probably they have lowest possible internal resistance. They should work at the cold temperatures, and they should have 500 of rechargeable cycles. Obviously I will not able to check the amount of cycles, but I will able to check internal resistance, remaining capacity. In out of the box condition, let's open them. So fancy package. Oops. Also 2000 milliamp hours, but the called Fast Flash, Recycle Pro Fast Flash. So let's check and see, do we have any difference between these rechargeable types or not. Let's start with this one, normal recycle, and then compare it with another.
here is the first rechargeables from GP in our test, GP Rechargeable, just normal Rechargeable. And as you can see, internal resistance are quite low. It's growing a bit at the very end. Power is about 2.25 watt hours, and capacity is just about 100 milliamp hours, but this is results off the shelf, so we can tell that okay, maybe they have not fully charged, but they should hold charge for decent time, and you can use them just after you bought them. Let's take a look at what we will have after some cycling. Here we have raw data from after some cycling, and as you can see, capacity is growth a bit, but it's much lower capacity than they should have. They should have 2.7 amp hours, and actually we have something about 2200 milliamp hours. Internal resistance are quite low, and they handling currents up to 0.5 amp without problems.
Okay, now let's check this Rechargeable Plus Pro, like professional rechargeables, and see is there something that makes them professional, that makes them better than normal Rechargeable.
Here we have the data for Rechargeable Pro off the shelf, and actually it's quite similar to previous ones, except the capacity is a bit lower, about 1.6 amp hours. Internal resistance also quite low, and they handling the loads very well. Let's take a look what we will have after some cycling. And here we have something really interesting here. Actually, it's the first time when I see something like that. Yes, we have capacity slightly lower than we should have, because we should have 2 amp hours. Capacity is slightly lower, the handling load very well, typical for rechargeables, doubly rechargeables. But take a look at the internal resistance. First time when I doing this, I see negative values. Obviously, it's a differential resistance, so negative values just meaning that at 0.5 amp it has slightly bigger voltage than 0.1, which is I think it's nonsense. It's just because my device is not suitable for measuring such low values, but this means that this Rechargeable Pro has some super low internal resistance, much lower than normal Rechargeable and much lower than even Lithium GP cells. It's quite interesting. As for me, I never saw this before.
And last type for today, Rechargeable Pro Photo Flash. By the way, we have GP also here. Interesting package. I never saw something like that before. And they feel a bit different. This plastic wrapping feels a bit different than in normal Rechargeable and with just simple Rechargeable Pro. Also they have green lines. Let's see if they have some difference inside, not just only outside.
And here we have our raw data for the Rechargeable Pro Photo Flash, and they should provide a quick recovery for Photo Flash, so I think they should have even lower internal resistance, because it's a main limiting factor for powerful devices like Photo Flash. Off the shelf we have about 1.5 amp hours capacity, not too much actually, and off the shelf we have really low internal resistance, yes, and it's growing only at the very end, so the shelf we have decent picture, except for capacity. It's quite slightly lower than we expect from modern AA rechargeables. But let's take a look after what we will have after some cycling, and wow, yes, capacity is still a bit lower than it should be, probably because it needs some more cycles to wake up, and internal resistance are super low, so it seems like these batteries they should work pretty well at the high loads, like a photo flash, and I never saw this before. This is quite super low internal resistance. So probably this Rechargeable photo is just the best for high performance tools, high performance devices like cameras. So I really excited about these results. And let's go to final comparison charts. Here we have comparison charts for capacity, and from just capacity, from milliamp hours point of view, it looks like, except lithiums, the best one is GP Ultra Plus. It has a lower current, 0.5 amp, it has 2.5 amp capacity, so if you need to power something with linear regulator, it's something that only power it with current, and it has low current consumption. I think GP Ultra Plus will be best choice for this. If you have something with high current consumption, you should take some of rechargeables, probably just normal Rechargeable, because it has bigger capacity than all others at 0.5 amp, except lithium ones. So highest capacity at the highest current. From all GPs, it's a normal Rechargeable series 2700. They have maximum capacity except lithium. Lithiums obviously has best characteristics, but they also quite pricey. Let's go to energy comparison, and here we have a slightly different picture, because rechargeables has lower voltage. We have the same leader is GP Ultra Plus. GP Extra is also seems well, looks well at the low current, and obviously lithiums are the best from energy perspective also, but again lithiums are quite pricey. Sorry. What about rechargeables? Well, they at lowest current they probably can compete with some alkalines at low current, but at high current they will outperform alkalines. They will have bigger energy output. These zinc-carbon ones, 1 and 2, power cell and green cell, they are looks like a joke, for I don't know. Actually, it's quite low characteristics. And most interesting part, let's take a look at the internal resistance. If you have some device that requires lots of power, or you have digital device, internal resistance will be most important thing that you should take in the account, because high internal resistance will limit your device ability to work. It will stop working not because there are not enough voltage, but most likely because there are too much internal resistance, and at the current spikes battery will just not able to provide enough power. And what do we see here? Here we see that this is zinc-carbon batteries. They have a huge internal resistance even at the very end, even at the very beginning.
Then we have alkalines, almost the same picture for all alkalines, except, surprise, surprise, GP peak power. So for some reason, peak power has slightly lower internal resistance at the very end of discharge, at 1 volt and 600 millivolts. So it seems like peak power probably will work slightly longer if you have a powerful device. If you have not so powerful device, well, Ultra Plus should be fine. It has a slightly bigger internal resistance than other ones. Lithiums have really low internal resistance at the almost all energy states, almost all battery life, and this bar's almost irrelevant because it will spend 99% of time here at this state because its voltage is quite stable. And really interesting moment, our rechargeables. For the Rechargeable we have really low internal resistance, it's quite good. But for Pro Photo and just Pro, here we have off-the-shelf, and off-the-shelf for Rechargeable Pro and just Rechargeable Pro after some cycling, and the same off-the-shelf Pro Photo and Pro Photo after some cycling. And as you can see, after some cycling, not off-the-shelf, but after some discharge cycles, we have really low and even negative, which obviously not sense, but my device just not suitable to measure so low internal resistances. We have even negative internal resistance here, so this means that the Rechargeable Pro Photo is a really good battery for demanding devices, for devices that requires lots of power. And this it's actually not only important for digital devices, it's important for almost everything that requires a lot of current, because with lower internal resistance we will have low energy waste inside the battery, so more energy will go to the load. They have much higher efficiency. So this is quite interesting. I really surprised. What I will recommend to you, so if you have some devices that requires lots of power, just buy the Rechargeable Pro Photo. Yes, they are quite expensive, but the internal resistance is very best. If you have just general usage devices and you changing the batteries one time per month or more often, just buy normal Rechargeable. They have also really low internal resistance, decent capacity, almost like alkalines, and you will save your money. And if you have some device that requires new set of batteries every month or less often, maybe one time per 2 or 3 months, I think Ultra Plus it's the best battery from GP, best alkaline battery. And special case is lithiums. Probably you should try to use them in your digital camera if you need to have spare batteries and you want your photo set to be light as possible, just because they have a lot of capacity and you will able to make a lot of photos with them. Probably without flash. If you will use flash, if you will use lots of power, probably you need to take a Pro Photo. So sorry for quite long video. Thank you for watching. I hope you enjoyed it. Please write in the comments what batteries you want me to test next. Maybe you have some questions, anything. Just feel free to leave a comment. Thank you for watching and have a nice day. Bye. And for those who really interested in this video and who still watching, here I have small bonus. Here I have 2 GP green cells. This one is familiar to you, we tested them in this video. This one is bought in April 2023, so this one is really new. And this one has expiration date of 07 2009. So this one is expired. How long? This one is expired 14 years ago. This one is really old GP green cell, but it's still green cell. And here I have battery tester. Let's try to test them. First we will test this one. It's a new one, not tested, not discharged, just out of the box, completely new. And we have here good battery. Okay, let's test this one. This one expired 14 years ago, and I believe it has about 17 years of life, shelf life. Maybe not shelf life, it's 17 years old. And as you can see, literally nothing happens. Oh no, probably we have small movement of the needle, but almost nothing. Completely died, you may say that this one is discharged and nothing remained here. But let's try to measure the voltage. And 142 volts. How it can be? Let's try again. And let's measure voltage at the new one. Yeah, slightly higher. The thing is, this one is from my calculator. It stays there for a really long time. It was there when I bought this calculator, so it was installed at the factory. And calculator still works. Actually, I disassembled the calculator and removed the battery, not because the calculator stopped working, but because I wanted to show you this part of video. I completely forgot that I had also GP in calculator. And let's test the current. It has a voltage, but it seems like it has no current because this tester trying to make some load. Just 3.4 milliamps, and it's growing. Actually, it's growing. So it's not completely discharged. It's just really aged. And let's try a new one. Oh, over limit, more than 200 milliamps. Obviously, because we in our tests we tested them at the 0.5 amp. So let's check what current we can obtain from these ones. Yeah, come on. 3.5 amps. And here we have nothing. So it looks like these batteries can work well in devices that require a really low amount of power, like calculators, and this one is not leaked. I believe it's dried somehow, so water inside it's evaporated mostly, and because of that it can't generate any current, any significant current, only about 3 milliamps, which is actually just ridiculous. But it still works in calculator. So for devices like that, these batteries is cheap power for years, for 70 years, and I believe it can work many years more. And batteries like that will not leak. I believe alkalines are hermetically sealed, and after a long time this sealing may fail and they may leak. But these ones, as we can see here, they mostly drying, not leaking. So probably it's just a really cheap way to power devices that require only tiny fraction of power. So probably we will see some sensors, some Bluetooth low energy, or maybe some other really low energy, low range wireless sensors we will see them powered by zinc-carbons, just because they are cheap, they are not leaking, and they are more or less harmful for the environment. Thank you for watching. Actually, let me know in the comment if you watched this, if you stayed for that long. Stay tuned. So, thank you, have a nice day, bye bye.